What's up, guys? Welcome to the River Project. Our team name is the River Monsters. My name is Dylan McMahon. I'm an environmental engineer intern, and this is the rest of our team.
I'm Walter Carsons. I'm a bio and ag intern.
Hello, I'm Brennan Masson, I'm a mechanical engineer intern.
Hi, I'm Vikram Kaushik and I'm a biomedical major intern.
The first step we had to go through in our engineering design process for the River Project was to define the problem. And the first thing we had to do was design and 3D print an innovative fish passage structure that mimics natural habitat in the stream and reduces flow velocity while maintaining necessary flow depths for a targeted fish species. The reason this was a problem is because in the past, people would just put rocks and tires and other debris like logs to make J-hooks and different fish structures for the water to slow down and then fish to pass through freely. But the reason that didn't work is because on the front end, it would slow down the water, but after it would get past the rocks and stuff, it would speed back up and erode a bunch of the banks and rocks and just make not a good habitat for the fish.
The second step of the engineering design process is planning solutions. So as Dylan said, we had to create an innovative weir-like structure that would regulate water velocities before and after passing the weir while maintaining a sufficient level of depth after passing the weir. So to tackle this problem, we brainstormed different structures to do this, and we had to ensure that our weir would have holes to allow fish to pass through, as this was also a requirement for the project. But along with this, we had to ensure that the holes weren't too big, as this would allow more water to pass through and it wouldn't reduce water velocities. So we thought of different structures that would help accomplish the task the best.
For the third step in the engineering design process, we have number 3, make a model. So the point of making our model, we had to redesign this one, which was our starting point from Weaver Labs. The problem with this one is, 1, there was no fish passage, which was a requirement of the project. And number 2, on this back end, the water was coming off so violently, which was what was causing the erosions. So then we redesigned, moved over here. 1, because we had to incorporate the passages, and 2, to incorporate the fish ladder part, which was in hopes of reducing the velocity on the back end. Well, the problem with this one was we had this flat surface in the front, which just caused too much backflow and caused too much water here and not enough right here, not enough flow. So then we moved here, which we incorporated a slope here, which did slow down the backflow right here. It helped it a bit on this side, but it was too fast on this side because of the slope. So then we moved here, which we flipped the slope, which also helped with the backflow, because this way the water will come up instead of over, which creates more backflow here, slowing the velocity here while keeping our same fish ladder style. And also with this one too, you can't see it, but on the bottom side we had to incorporate the hook so that it's able to be tested inside the flume. And this is what we have with our design here.
The next process was to test the model, and here you can see our model in the water where the water is being slowed down and then spit back out at a different velocity, and then towards the end you can see where the water rises back up.
Alright, so number 5, reflect and redesign. So first year engineering design day was a great experience. We got to see a bunch of brilliant projects and minds all together in one room, as well as showcase our hard work and talk about our project. At Fed, our team got an honorable mention, which I believe is 3rd place. All in all, it was an enjoyable project compared to others, and an enjoyable experience all around. So if we had to change our project, the water velocity coming off the edge was a little bit fast. It was measured at 3 different points, one in the beginning, one right after, and one at the very end. The velocities and water levels at the beginning and at the end were good, but right off the edge it was a little fast. So if we could change that, we would have rounded off all the edges just so the water could come off more smooth and slow it down a little bit. Or if we had even more time, we would have redesigned it completely, because I believe the winning project was something like this, where the water would go through and the fish would go through, but there was little like pieces that would make it so the water would have to go around and would really slow it down, but fish could also drown. So if I had to give any advice for freshmen next year doing the river project, I would say to start everything early, all your designs, and communicate with your team members.
If I had to give one piece of advice about the river project, it'd be to square away everything 3D printing related early, whether that's AutoCAD, your safety orientations, or anything else 3D printing related. Because especially with these 3D printing, as many times you're gonna have to do it, they're gonna take it from anywhere from 10 to 20 hours to finish, depending on how complex your design is.
So this was the River Project by the River Monsters. Thanks for watching. Hope you enjoyed.